Okay, we're going to solve this system again using elimination. So step one is going to be to number them, right? We want to be able to identify our equations, okay? And so looking at my equations, I've got the first equation, second equation, third equation. I'm just trying to decide which is going to be easier to eliminate. And let's try to eliminate the x variable. We haven't done that yet. So if I take equation 3 and I multiply it by -4, what that's going to do for me is it's going to give me a -4x. And when I add that back to equation 1, it's going to cancel out the positive 4x. So again, multiplying equation 3 by -4. Okay, that's going to give me -4x plus 12y minus 4z equals -16. And if I add that to equation 1, again, I said that my x variable will cancel out, and it does. -4x and positive 4x make 0. 12y and -9y make positive 3y. -4z and positive 10z are going to give me 6z. And -16 and positive 9 is going to give me -7. So now I have a new equation number 4, right? So now I got to go back to my other two equations and I got to pick a new pair. Okay, so looking at equation 2 and 3, I want to try to eliminate x again. So I'm going to take equation 3 and multiply it by -3. Okay, so this is going to give me -3x plus 9y minus 3z equals -12. And if I add that to equation 2, again, I'm going to see that my x term cancels out. 9y and -6y will make 3y. -3z and 9z makes 6z. And -12 and positive 5 give me -7. So what happened here is when again, this is equation 5, right? When I eliminated x in my two pairs, I actually came up with the exact same equation. Equation 4 and equation 5 are exactly the same. So if I were to go through and multiply one by -1 and add it to the other one, everything cancels out, and I get this statement of 0 equals 0. And naturally, we would be like, well, obviously, 0 does equal 0. But what this means is that we have an infinite set of solutions. And that we would consider the system to be consistent because there's at least one solution, but the equations themselves are dependent.